Good evening, ma'am.
Good evening, sir. You can start now, sir.
Yes, ma'am. The next concept in the basic concepts of chemistry . The previous class we learned about the units and dimensions, fundamental units and derived units, and also we learned what is precision and accuracy. This is important. Scientific notation. Now, what is the scientific? For an example, Avogadro's number. Is represented as Na, and Avogadro's number, it is 6023 1 2 . So this is the number. This is the large number. It is not possible to represent this huge number like this. Or if we have a very small number. Now, for an example, if I have a very small number like this, to represent this number also is difficult. So we represent very large number or very small number in terms of scientific notations. In scientific notation, the large or the small numbers are expressed in this format, n into 10 to the power n, or number between 1.0 to 9.99 multiplied or divided by an appropriate number of times. Now, for an example, where, before we take an example, where n is the number between 1.00 and 9.999, and n is the exponent. Now, for an example, if I take this number 6.023 into 6.06023, you have 23 numbers. After 6, we have 23 numbers. So 23 zeros. So we can write this as 6.023 into 10 to the power 23. This is the scientific notation of Avogadro's number. Instead of writing this large number, we can represent in this format. Now you can see this capital letter N, it should be between 1.0 and 9.999. So here it is 6.023. And 10 to the power, n is an integer. So here we have 23. So I've written it as 10 power 20. Now for an example, this number, if you observe, we have a decimal point here, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So after the decimal, we have 9 digits. We can write this as 2.45 into 10 to the power. We're shifting the decimals here. 1, 2, 3, 4, 5, 6, 7. In the 7th place, we're placing the decimal. So 10 to the power minus 7. This will be the scientific notation for this value. We cannot write this as 24.5 to 10 to the power minus 8. We cannot write. This is wrong because the capital N value should be between 1.000 and 9.999. It cannot be above 10 or it cannot be below 1. So we cannot write this as 0.245 into 10 to the power minus 6. We cannot write. This also is wrong. So the scientific notation, the n value should be between 1.00 and 9.999. This is the value for n in order to represent any large number or a small number in scientific notation. There are examples given here also. I'll use the eraser and so that I can explain the examples given here. Now, if you can observe the first example given here, it is 138.42. 138.42, we can represent it by means of a scientific notation in this fashion. 138.42. So the n value should be between 1 and 9.999. Therefore, what we can do is we can shift the decimal point towards the left, 2 decimal points. So it will be 1.3842. Since we are shifting the decimal point to the left, the exponent will be positive. Since we are shifting it 2 times, it will be 10 to the power 2. Now, in this example, if you observe, we have shift the decimal point to the right. So 1, 2, 3, 4 times. So it will be 1.3842 into 10 to the power minus 4. This is a scientific notation for this value. So here it is power, it's not 1 or 2, it is 10 to the power 2, and it's 10 to the power minus 4. Exponent is minus 4 in the second case. Now, scientific notation, under the scientific notation, now to transform a number larger than 9.999 to scientific notation, the decimal point, there is only one non-zero digit before the decimal point. If the decimal point is moved x places to the left, then now the decimal point is moved x places to the left. So these all is power 2 here. It is not 103, it is 2. Now, the first example we already learned. Now, 138.42. In order to represent this by means of a scientific notation, shift the decimal to the left, 2 decimals. So when you shift the decimal to the left, we have 1.3842. Since the decimal is shifted to the left, the exponent will be positive, and we are shifting the decimal by 2 digits, therefore it is 2. 1.3842 into 10 power. Here, the second example, we are given 1395.2. This also can be written 3 decimals, 3 digits we are shifting. So in 1.395 into 10 to the power 3. And here you can see the fourth one. We're shifting it by 1 decimal. So 2.1654 into 10 to the power 1. This is the scientific notation. So larger number to the smaller number we learned here. The power will be positive. The exponent will be positive. If we're representing a larger number into scientific. Transform the number smaller than 1 to the scientific notation. The decimal point is moved to the right until there is 1 non-zero digit before the decimal. Digit. Non-zero means other than 0. Now for 13482. Now this is a very small number. It is much lesser than 1. Therefore, if we have to represent it by a scientific notation, this decimal has to be shifted to the right. 1 place, 2 place, 3 place, and the 4th place. So when you shift it by 4 place, we can write this as 1.3482 into 10 to the power. Whenever the decimal is shifted to the right for a smaller number, the exponent will be negative. Since you're shifting it by 4 digits, it's 10 to the power minus 4. Similarly, the second example, 0.005549. This will be written as 5.49, 3 digits, 1, 2, and 3. The first one should be a non-zero. The decimal point is moved to the right until one non-zero. So 5 is a non-zero into 10 to the power. Since we're shifting it 3 times, 3 digits, it will be minus 3. And 0.1641. So the scientific notation for this is only one decimal. So it will be 1.641 into 10 to the power minus 1. This all are in minus. This is minus 4. This is minus 3. And this is minus 1. So this is how we represent the large number as well as the small number in terms of scientific notation. Now the next concept is the significant figures. What is the significant figures? Now, to express the result in accurate way, we express generally those digits which are known with certainty. This is done in terms of significant figures to express the result in an accurate way. Scientific, in chemistry or physics or mathematics or any science subjects, we learn by experiments. When you do experiments, the answer has to be expressed in terms of in digits which are known with certainty. Significant figure is a number, and are all the certain digit plus one doubtful digit. Significant figures in a number are all the certain digits plus one doubtful digit. The digit in a properly recorded measurement are known as significant figures. The greater the number of significant figures in a reported result, smaller is the uncertainty and greater is the precision. So greater the number of significant figures in a report, greater the number of significant figures in the result, smaller is the uncertainty. Uncertainty is out. Certainty is no doubt, it is authenticated result. So when the significant figures are more in number, then the doubt or uncertainty is very small and precision will be greater. Now there are rules to be learned in order to understand the significant figures. Rules for determining number of significant figures. So there are more number of rules, and we will follow the rules with examples, and then we will conclude the significant figures by using simple mathematics like addition, subtraction, multiplication, and division. Rules for determining the number of significant figures. It is only the number, whether it's 1, 2, 3, 4. All non-zero digits are significant. Significant means it contributes, it is important. So all the non-zero digits are significant. All the non-zero digits are having a significance. We cannot ignore them. Now, for an example, in this number 1.887, there is no zero here. All these are non-zero numbers. So all these non-zero numbers, whether the number is before the decimal or the after the decimal, all are significant, all are contributing, all has importance. So therefore, the number of significant figures in 1.887 is 4. The second example, the number of significant figures in 12.612. Here you can observe there is no zero here. So all the numbers are non-zeros. So all the non-zero digits are significant. So how many non-zero digits we have? 1, 2, 3, 4, and 5. Therefore, the number of significant figures in this number is 5. Now, the number of significant figures here is 1.23. There is no zero here. So all the numbers are significant. Therefore, the total number of significant figures here in 1.23 is 3. If I ask you a question, what will be the number of significant figures in 123? 123. It is again 3. What is the number of significant figures in 12.3? It is again 3 because all these are non-zero. 1.23 has the same number of significant figures as 123, and 1.23 has same significant figures as 12.3. So all the non-zero, the first rule is all non-zero digits, all non-zero numbers are significant. The second one, when the number is greater than 1, this rules you should remember. Second rule, this is when the number is greater than 1, all the zeros to the right of the decimal point are significant. When the number is 1, all the zeros to the right of the decimal point are significant. All the zeros to the right of the decimal point are significant. Now, the number of significant figures in 3.0, 3 is greater than 1. There's a decimal, and we have a 0 here on the right side. This 0 is also significant. As per the rule, when the number is greater than 1, all the zeros to the right of the decimal point are significant. So this 0 is on the right side, therefore it is a significant figure. So the number of significant figure in 3.0 is 2. So the number of significant figure in 91.070 is the decimal. See, 91 is larger than 1, no doubt about it. And zeros are present on the right side of the decimal. Since zeros are present on the right side of the decimal, they are significant. So 1, 2, 3, 4, and 5. The number of significant figures is 5. The next here, the number of significant figures in this 42.000. 42 is larger than 1. And as per the rule, zeros are on the right side of the decimal. Therefore, these all are significant. So totally, the number of significant figures is 5. 1, 2, 3, 4, 5. The first rule we learned, all non-zero digits are significant. All non-zero digits are significant. This is important, very important for competitive exams and also for your 11th standard. So all non-zero numbers are significant. Now, if I write 456, the number of significant figures will be 3 because no 0 here. Any number for that matter, all non-zeros are significant. The second point is, if the number is greater than 1, the zeros placed on the right-hand side of the decimal point are significant. So here, in this case, 3.00. So what will be the number of significant figure? Number of significant figures will be 3. If I write 3.000, so number of significant figures will be 5 here. 4 zeros are there after decimal, and this also is significant. So number of significant figures is 5. So if the number is greater than 1, and if zeros are placed on the right side of the decimal point, all those are significant. A third rule, for a number less than 1, only zeros to the right of the significant digit are significant. Only zeros to the right of the first significant digit are significant, but the zeros to the left of the first significant digit are not significant. So decimal is here. The first significant figure is 4. As per the rule, the 0 which is on the right side of the significant figure is significant. This 0 is significant. This 0 is not significant because it is before the decimal point. It's towards the left of the first significant point. Therefore, this is not significant. So the number of significant figure here is 4. This 0 is not counted. Similarly here, 0.0013, the second example you can see. The first significant number digit is 1 here. The statement clearly says the zeros to the left of the first significant figure. The zeros to the these zeros are not significant now because it's in the left. They are not significant. So number of significant figure here is only 2. There's 1 and 3 example, if you observe 0.0002, the number of significant figure is only 1 because the first significant figure is 2 here, and zeros before the first significant figures are not significant. Therefore, the answer is 1. These kind of questions are asked in your 11th standard exams. Also in the competitive exam, they can ask you problems based on this. We'll work on it. Now, the last example here in this case, 0.0302, the 0.030. The first significant figure is 3. This significant figure, which is before 3, is not significant. This 0, which is significant figures of 0.030 is 2. The first point is all the non-zero digits are significant. The first point. Second point, zeros present on the right side of a non-zero is significant when the number is greater than 1. When the number is greater than 1. The third point, if the number is less than 1, only zeros to the right of the first significant digit. So the first significant digit is 4 here. This is significant. The first significant figure is 1. The first significant digit are not significant. This is the third rule. The fourth rule, a zero becomes more significant if it comes between non-zero digits. The fourth rule is the zero becomes more significant, more important if it comes between two non-zero digits. Now you can see here the example, 3.01. So 3 is a non-zero, 1 is a non-zero. So between 3 and 1, this 0 is present. So this 0 becomes significant. Therefore, the number of significant figure is 3. 6.023. 6 is non-zero. Therefore, this becomes significant. So number of significant figure is 6.02. Its number is 4. So here you can see 3 is non-zero, 2 is non-zero. These zeros are present between 3 and 2. Therefore, this becomes at most significant. So therefore, the number of significant figures 1, 2, 3, 4, and 5. So it is 5. So zeros between non-zero digits are more significant. Now, this is important. Addition. Now we are going to learn some of the problems. Rules for determining the significant figures. And the first one, what we're going to talk about is when adding or subtracting. When adding or subtracting, the number of decimal places in the answer should be equal to number of decimal places in the number with the least number of decimal places. With the least number of decimal places. So there's a spelling mistake here. The spelling mistake here. That's okay. Now, when adding or subtracting, the number of decimal places in the answer should be equal to number of decimal places in the number with least number of decimal places. So here 3.21, the 3 significant figures with 2 decimal places. Now here we have 1.5. The number of significant figures is 2. But the figures and with 1 decimal point means when we add 2 or 3, we'll take some examples and we'll understand. Now for an example, okay, maybe we'll write here 4.50, maybe 5 I will take for understanding a simple example, then we'll go for the complex ones possible. .55, and this is added to added with 1.4. Now, in this case, the number of significant figure is 3. And in this case, number of significant figures is 2. That means when we add, the answer what we get should have only 2 significant figures. So it means we should make the answer in only 2 significant figures. Now, for an example, for this, it will be 5, 9, and 5.95. So this has 3 significant figures. We cannot represent this answer to be in 3 significant figures like this. We have to make it to 2. How do we do that? We will learn in the following slides. So when adding or subtracting, the number of decimal places in the answer should be equal to the number of decimal places in the number with the least number of decimal places. So here the number of decimal places is 2, 5, 5. Here the number of decimal places is 1, only 4. Therefore, the answer should have only 1 decimal place. It cannot have 2. That is what it means. The next point. Here you can see 21.402. 5 significant figures. So all are significant here. But this is having 3 decimals. This is having 3 decimals. This is 2 decimals, 1 decimal. And here's an example for a number with 5 significant figures and 3 decimals. Now, if I write like this 214.02, it is again having 5 decimal figures, significant figures, but the decimal place is only 2. You should remember. Significant figure is 5 decimal places. It's only 2 decimal places, 0 and 2. Since the term 1.5 involved in addition has only 1 decimal place, the overall answer of 26.112 should be reported as 26.1. What is this? We will learn. The first one is 3.21. The second one is 1.5. The third number is 21.402. You have to add these 3 numbers. Now here you can see the significant figure is 3. The number of decimal places is 2. Here significant figure is 2. Number of decimal places 1. Here the significant figure is 5. Number of decimal places 3. Now when you add all these, let's see what we get. We get 2, 1 and 0. It is 1. And it is 9, 10, 11, 1 remainder 2. So this is 26.112. The answer is 26.1. But as per the rule says the number of decimal place in the answer should be equal to number of decimal place in the number with the least number of decimals. So which is the least number of decimals here? Here, only 1.5. It is only having 1 decimal. Since we have 1 decimal place, we have to give the answer in terms of 1 decimal place. Therefore, we write the answer to be 26.1. It is not represented as 26.112. It is represented as 26.1. So this is with respect to addition. Now the 6th rule, and subtraction also same. Subtraction also same. We'll take one example for subtraction here. 6.02. Maybe we'll take a bigger number, 6.82 minus 2.41 minus 4.21. 4.2. We'll not take 1. We will take 4 point because the decimal place becomes same. So here, excuse me. So here, when you subtract, it is 2. 4 minus 8 minus 4 is 4. Decimal 4 or 6 minus 2 is 4. Now here we have 2 decimals, and here you have 1 decimal. So as per the rule, the answer should also have minimum decimal. So this is written as 4.4. So this is how you represent an answer for this. So addition and subtraction. Similarly, in case of multiplication and division also. In multiplication and division, the number of significant figures, this is 6th rule. The number of significant figures in the answer should be same as that in the number with the least number of significant figures. Answer should be having the least number of significant figures. In multiplication and division, the number of significant figures in the answer should be same as that in the number with least number of significant figures. Since the term 3.376, it has 4 significant figures. And 1.25 has 3 significant figures. So when you multiply this 3.376 into 1.25, the answer we get should also have the answer somewhere you get 4.22. So the answer, it also has to have only 2 decimal places or 3 significant figures. Totally, we have 3 significant figures here. Here we have 4 significant figures. As per the rule, the answer should be same as in the number with least number of significant figure. So here we have 3 significant figures. So therefore, the answer also should be given in 3 significant figures. The next rule, when the number is rounded off, this people get confused, we should understand. When the number is rounded off, the number of significant figure is reduced. The number of significant drop is greater than 5. The last retaining digit, the last LAST, last retaining digit is increased by 1. For an example, in this case, you can say 12.6. Since the number is rounded off to when the number is rounded off, the number of significant is reduced. The digit we dropped is greater than 5. See, this digit has to be dropped, and this digit is greater than 5. When this digit is greater than 5, the last retaining digit is increased by 1. So the last retaining digit is 2 here, is increased by 1. So the answer is expressed in terms of 30. Now, for an example, 12.467. Assume. Now, we have to express this answer in terms of 4 significant figures. Now, if you have to express this answer in 4 significant figures, you can see this has to be dropped. And this is greater than 5. Since it is greater than 5, the last retaining digit is 6. To this, we have to add 1. So the answer will be 12.47. 12.47. This rounding of the number of significant figures. Now, when the number is rounded off, if the number is rounded off, the number of significant figures is reduced. If the digit to be dropped is less than 5, the digit to be dropped is less than 5, the last retaining digit is left as it is. The last retaining digit is left as it is. Now, 4, and the number of significant figure is 3. Now, the answer has to be retained in 2 significant figures. The significant figure and the answer should be 2. If that's the case, this has to be dropped. But this number which has to be dropped is less than 5. Since the number which has to be when dropped is less than 5, so we round it off to 12. The answer is retained as 12. So if it's more than 5, add 1. If it is less than 5, retain the same. When the number is rounded off, the number of significant figures reduced. If the digit to be dropped is 5, it is neither above 5 nor below 5, it is 5. If it has to be 5, the last remaining LAST, last remaining digit is increased by 1. If it is odd, is rounded to 12. See, this is odd. 11 is an odd number. So we have to drop this. Therefore, what we are supposed to, as per the rule, the last remaining digit is increased by 1 because this is odd. Now 12.5, 12 is even. We have to drop this number. Since this is even, we round it off only to 12. This is left as such. These are the rules in order to determine the significant figures. Major rules, few more. When the number is rounded off, the number of significant figures reduced. The last digit retained is increased by 1 only if the following digit is 5 and is left as such if the following digit is 4. The number is rounded off. The number of significant figures reduced when the number is rounded off. The last digit retained is increased by 1 only if the following digit is 5 and is left as such if the following digit is 4. Now 12.696, 18.35 and 13.93 are reported as 12.696. Now you can see here, this is greater than 5 and this is also greater than 5. So we have to increase this. So it will be 12.7. So 18.35. Now here it's 5 and this is odd. So therefore we have to add 1. So it will be 18.4. Now next 13.93. This is to be dropped and this is less than 5. Therefore we write the answer to be 13.9 itself. These are the rules in understanding the significant figures. There's a lot of numbers to be worked based on the significant figures. So, and when we work the questions, we will try to understand the significant figures. The rules, again, for your understanding. The first one, all non-zero digits are significant. Greater than 1, all the zeros to the right of the decimal point are significant. When the number is less than 1, only zeros to the right of the first significant digit are significant, but zeros to the left of the first significant digit are not significant. Fourth point, 0 becomes significant if it comes in between two non-zero digits. This is significant because 2 is between the non-zero digit. When adding or subtracting the number of decimal places, in the answer should be equal to the number of decimal places in the number with least number of decimal places. So I have given you this example. So in addition of 3.21, 1.5, 21.402, 1.5 has 1 decimal. Therefore, the answer to be retained in 1 decimal. It's 26.1, not 26.112. Similar in case of multiplication also. We have learned the number of significant figures in the answer should be same as that in the number with least number of significant figures. When the number is rounded off, the number of significant figures is reduced. Similarly, with rounding off, we have learned it with detail. Now, chemical classification of matter. Classification of matter. What is matter? Anything that has mass and occupies space is called as matter. Anything that has mass and occupies space is called as matter. Now, for an example, the duster your teacher will be using in the class. This duster has a definite mass and it also occupies a definite space. Therefore, duster will be called as a matter. Likewise, the chalk. Chalk, it has a definite mass and it also occupies certain space, specific amount of space. Therefore, chalk will be also called as a matter. The pencil, pen, the notebook is called as matter. Any substances that has mass and occupies space is called as matter. Matter can be classified into 2 ways. First one, in physical classification. Matter is broadly classified into 2. One is the physical classification, The other one is the chemical classification. Now, in case of physical classification, matter is classified as solid, liquid, and gas. In case of chemical classification, matter is classified as a pure substance and impure substance, a mixture. Pure substances are further classified as, where is that? Elements, compounds. These elements are classified as metals, non-metals, and metalloids. This mixture or impure substances are classified as homogeneous and heterogeneous mixture. Now, matter, as we learned, anything which occupies space and which has a definite mass is called as a matter. So matter can be classified broadly into two. One is the physical classification. The other one will be the chemical classification. Physical classification are further classified as solids, liquids, and gases. We will learn what is solid, what is liquid, and gases in the following classes. Now, again, this chemical classification is further classified into two pure substances and impure substances. Pure substances are classified as elements and compounds. These elements are classified as metal, non-metals, and metalloids. We'll have to learn what is an element, what is a compound, what is a metal, non-metal, metalloid. With definitions and examples, we'll be learning it. Now, the impure mixture, they are classified as homogeneous as well as heterogeneous mixture, homogeneous mixture and heterogeneous mixture. Now, physical classification of the matter. The physical classification of the matter, depending upon the physical state of the matter, it can be classified into solids, liquids, and gaseous state. So based or depending upon the physical state of the matter, physical state, it is classified into solid, liquid, and gases. Chemical substances or chemical classification of matter. This chemical classification of matter, based on the chemical composition, they are classified into three: elements, compounds, and mixtures. Now, what is an element? Element is a pure substance made of same kind of atoms, are called as elements, or is called as elements. Substances made of same kind of atoms are called as elements. Now, for an example, hydrogen, oxygen, nitrogen, sulfur, these are all elements. Because all these are made up of same atom. H2 is made up of hydrogen atom. Oxygen, O2 is made up of oxygen atoms. And nitrogen is made of nitrogen gas is made of nitrogen atom. Sulfur is made of sulfur atoms. So pure substances made up of same kind of atoms are called as elements. Now, compounds, they are formed by chemical composition of atoms of different elements in the formation of, during compound formation from their elements. The properties of compounds are totally different from the element from which they are formed. A compound can be organic or inorganic. Now, for an example, now if you take nitrogen and oxygen, nitrogen is called as an element because nitrogen gas is made of nitrogen atoms. Oxygen is also called as an element because oxygen gas is made up of oxygen atoms. When these combine, nitrogen, oxygen, and combine, we get nitric oxide. This nitric oxide is a compound. They are formed by chemical composition of atoms of different elements. So two different elements, when they combine in specific ratio, definite ratio, we get compounds. Here, nitric oxide is an example for a compound because this contains two different elements. Since this is made of two different elements, the properties of nitric oxide will be different compared to oxygen and nitrogen. Now, one more example, nitrogen and hydrogen reacts to give ammonia. Nitrogen is an element, hydrogen is an element, ammonia is a compound. So ammonia will have different properties compared to nitrogen and hydrogen. Mixtures, a combination of two or more elements or compounds in any proportion so that components do not lose their identity is called as mixtures. See here, it's in this case as examples, it is in definite proportions. They react in definite proportions. But in case of mixture, the combination of two or more elements or compounds in any proportion, in different proportions, so that the component do not lose their identity. That's called as mixtures. And the mixtures of two types, homogeneous mixture and heterogeneous mixture. Homogeneous mixture have same composition throughout the sample. Homogeneous mixture have same composition throughout the sample. For an example, air. Air contains nitrogen, oxygen, carbon dioxide, and all the other gases. And throughout the sample, the composition remains the same. Likewise, alloys. Alloys are the combination of metals. It's also an example for homogeneous mixture. Gasoline, petrol. Heterogeneous mixture, they consist of two or more phases which have different composition. Mixture of sand and salt. They have two phases, sand and salt, two different phases, and they have different composition. Now, exercise we will learn in the next class.
Yes, sir. Yes, sir. Thank you, sir.